Yes, so today we are going to start with packing in solids. Now in this, we are going to study how the atoms are packed. So packing in solids can be studied in three ways. One is one-dimensional, second is two-dimensional, and third is three-dimensional. So हम ये तीन वे में हम study करेंगे. So if I talk about one-dimensional, so one-dimensional atoms कैसे arrange होंगे? देखो, this is what the atoms. If I take more, you can see I'm arranging the atom in the linear form, which is called as one-dimensional. So this is what atom continuously linear form में होगा. So such type of packing, one-dimensional packing of solid is called as linear packing. क्या बोलेंगे इसको? Linear packing. Now, if you observe the coordination number, now what is coordination number? मैंने पहले भी बताया है, coordination number is the number of atoms surrounded. As you can see, if I talk about this atom, you can say this is what one of the atom attached and this is what the second atom attached. So coordination number for the linear packing is 2, correct? Coordination number for the linear packing is 2. ना स्वयं 4 नहीं आएगा, it will be 2. Linear packing की बात कर रहे हैं. चलो टू डायमेंशनल देखते हैं सब लोग. टू डायमेंशनल, ना टू डायमेंशनल कैन बी एक्सप्लेन इन टू वेज. देखो पहले, as you can see, I have arranged its sphere like this is what consider this is layer A. ठीक है? This is layer A. Second is what similar to the first, so again it's layer A. Third is again similar to the first, second, so this is what again layer A. So such type of packing, such arrangement of the atom is said to be A type arrangement. क्या बोलेंगे? A type arrangement. Okay. Now, if you see, it will form a square. As you can see, it will form a square. Square form कर रहा है. So it is also called as square closed packing. Square closed packing. And what will be the coordination number now? Coordination number क्या होगा इसका? Coordination number, correct, it will be 4. Now coordination number will be 4. कैसे पता चलेगा? Check करो. This is one sphere, second sphere, third and fourth, correct? So 4 spheres are in the contact to this atom. So it is called as coordination number 4. चलो टू डायमेंशनल का एक हमने देख लिया, फर्स्ट हमने देखा, अभी सेकंड देखेंगे. तो टू डायमेंशनल सेकंड अरेंजमेंट. चलो ध्यान से देखना. So now if you observe, this is layer A, correct? This is layer A. Now in this, the second is different than the first, so it is layer B. The third layer is similar to the first, so it is again layer A, correct? ये भी आपका layer B. So now this type of arrangement is called as AB type arrangement. Now if you observe, it will form an hexagon. It will form an hexagon. देखते रहो. This will form an hexagon. So it will be called as, इसको क्या बोलेंगे? Hexagonal close packing. It is called as hexagonal close packing. Yes, very good. Its coordination number is 6. Coordination number is 6. Coordination number 6. I hope everyone are clear. Okay. Next we'll move to 3-dimensional. हम लोग next 3-dimensional देखेंगे, ठीक है? ये हमारा 2-dimensional हो गया. Next we'll move to 3-dimensional. So for 3-dimensional again, देखो कैसे arrangement कहते हैं. As you can see, मैं यहाँ पे atoms को arrange कर रहा हूँ. Yes, as you can see, अब हम लोग क्या करेंगे पता है, ये पूरे लेयर को हम लोग ए लेंगे. दिस इज व्हाट ए, वन लेयर. हाँ, ये पूरा लेयर ए है. प्लीज नोट दिस whole arrangement is layer A. Now this is layer A. Now यहाँ पे मैं दो टाइप के वॉइड्स को टिक कर रहा हूँ. आप चेक करो, एक डॉट करके शो कर रहा हूँ. दिख रहा है सबको? ये सिंपल पिंक एंड ग्रीन कलर दिख रहा है. So one of the word is marked by pink color and one of the word is marked by green color. अभी ये क्या है वो आपको सेकेंड लेयर प्लेस करने के बाद समझेगा. नाउ विल प्लेस द सेकेंड लेयर. चलो सेकेंड लेयर डालते हैं। So we are placing the second layer. As you can see, is everyone clear? सबको दिख रहा है second layer? The red one is, so this layer is said to be layer B. Layer B. Layer B. Correct? Is everyone clear? Layer B सबको समझा? तो लेयर ए देखा हमने ब्लैक वाला, रेड वाला जो मैंने अभी शो किया, दैट इज लेयर बी। नाउ वी हैव टू टाइप ऑफ वर्ड एज यू कैन सी। आपको वर्ड दिख रहा है क्या? मैं आपको देखो हाईलाइट करता हूँ। वन मिनट। एक देखो आपको ये वर्ड दिखेगा और आपको एक ये टाइप का वर्ड दिख रहा है। दो डिफरेंट वर्ड दिख रहा है कि नहीं? यहाँ पे टू डिफरेंट वर्ड। वन इज समथिंग इन, एक कुछ आपको ट्रायंगल करके शेप दिख रहा है जो कि ब्लैक वाला है, बराबर। इसको आप क्या बोलते हो पता है? इसको आप बोलते हो टेट्राहेड्रल void. It is called as tetrahedral void. It is called as tetrahedral void. And जो आपको जहाँ पे ग्रीन कलर का दिख रहा है, जैसे कि आप ये देख सकते हो ग्रीन कलर दिख रहा है इसमें बीच में। तो ये कुछ पहले ट्रायंगल था, पहले स्फीयर्स था, फिर नेक्स्ट स्फीयर्स आए, फिर ऐसा कुछ ये फॉर्म हुआ। ये पूरा फिल हो गया है स्फीयर्स से। तो अभी जो वॉइड यहाँ पे दिख रहा है सबको, वो खाली इतना सा ही वॉइड है। इसको आप क्या बोलते हो? इसको बोलते हो ऑक्टाहेड्रल वॉइड। इट इज कॉल्ड एज ऑक्टाहेड्रल वॉइड। शॉर्ट में इसको OHV भी बोला जाता है, टेट्रल वॉइड को THV भी बोला जाता है। ओके, so now we have tetrahedral void and octahedral void. Is everyone clear with octahedral and tetrahedral void? Wait, Swam, wait. So now we'll have 2 points here, like point 1. If third layer, if third layer plays on tetrahedral void, if third layer plays on tetrahedral void, और दूसरा पॉइंट ये बनेगा if the third layer plays on octahedral void। तो अब ये क्या होता है देखते हैं, चलो। तो प्लेसिंग ए थर्ड लेयर ऑन tetrahedral void, please note, placing a third layer on tetrahedral void. Please note, I am again repeating, placing the third layer on tetrahedral void, जो कि ये ब्लैक वाला आपको दिख रहा है। चलो, so placing the third layer on tetrahedral void. So placing the third layer on tetrahedral void, as you can see, ये layer A को मैच कर रहा है कि नहीं? Layer A को मैच कर रहा है। Placing third layer on tetrahedral void is matching to layer A. Yes or no? Yes. So that means placing third layer on tetrahedral void give rise to AB type packing. AB type packing, which is called as hexagonal closed packing. Called as hexagonal closed packing. जिसको आप शॉर्ट में क्या बोलते हो, HCP. चलो now placing the third layer on octahedral void. Please note, placing the third layer on octahedral void. As you can see, वो मैच नहीं कर रहा है. क्या वो मैच कर रहा है लेयर ए को? लेयर ए को मैच कर रहा है क्या थर्ड लेयर प्लेसिंग ऑन octahedral void? ना. That means the blue one is layer C. So that means I can write as, if the third layer plays on octahedral void, give rise to ABC type packing, correct? Yeah, we can say arrangement, which is called as cubic close packing. Cubic close packing, called as CCP. Called as CCP. Is everyone clear? Understood? समझा सबको? So next we'll see what we have done till now. एक बार एक short revision कर लेते हैं. Yes, okay. So we have learned about simple cubic cell. We have learned about body center cubic unit cell. Then we have learned about the face center cubic FCC, which is also called as CCP. दोनों के लिए same ही आएगा, ठीक है? And we have done with HCP. HCP stands for hexagonal closed packing. Hexagonal closed packing. चलो फिर हम लोग अभी देखेंगे यहाँ पे type of packing. Type of packing present. So यहाँ पे it is called as A type packing, correct? BCC को आप बोलोगे AB. That is called as ABC, FCC and CCP cubic close packing. Just अभी देखा था हमने ABC close packing, and SCP को हमने again AB बोला है, AB, and this is what a close packing. Next, number of atoms. तो ये टेबल आपको हमेशा ध्यान में रखना है, ठीक है? It will help to you solve the numericals. The number of atoms for the simple cubic cell 1, body center 2, face centered as CCP 4, and hexagonal 6. Then coordination number. Coordination number 6 for the simple cubic, 8 for the body center, 12 for the CCP or face center, and again 12 for the hexagonal close packing. The next is about packing efficiency. Packing efficiency. And for simple cubic cell, it is 52.4%. BCC, it's 68%. 74%. SCP for 74%. Okay? And if I talk about some examples, so we have polonium, which show simple cubic cell. Then we have barium, vanadium, chromium, manganese, and Fe. Similarly, we have for face center calcium, strontium, aluminium, copper, nickel, and यहाँ पे आ जाएगा remaining D block element, as well as the like beryllium and magnesium. These are what the example. Clear? So next we'll see how to identify the number of octahedral void and tetrahedral void in closed packing. So in closed packing, so if number of atoms, please note, if number of atoms is equal to n, consider if number of atom is equal to n, the number of tetrahedral void, the number of tetrahedral void, that is equal to 2n. The number of tetrahedral void is equal to 2n. Short में इसको बोलते हैं THV. Similarly, number of octahedral void, which is given by OHV, is given by n. Like example, if we have a solid having a CCP structure, where is said the number of atoms for the CCP or FCC is what? 4. So anyone, what will be tetrahedral void and what will be octahedral void? So tetrahedral void कितना होगा? If number of atom is 4, yes, so tetrahedral void will be 8 and octahedral void will be 4. Clear? Radius ratio rule. First of all, this is only applicable to ionic solid. Please note, this is only applicable to ionic solid. Okay, and this what we do, we take a ratio of the radius of cation to radius of anion. We have to take what the ratio of the radius of cation to radius of anion. ये हमारा फॉर्मूला कैसे करेंगे देखते हैं हम लोग. So the first column will have limiting radius ratio formula, radius of cation, radius of anion, type of void, coordination number of the void, coordination number, and example. So the first range is 0.155 to 0.225. Similarly, the second range is 0.225 to 0.414. Next is 0.414 to 0.732. And the final is greater than 0.732. Now, if the value of the ratio of the radius of cation to radius of anion lie between the first range 0.155 to 0.225, the geometry of the void will be planar trigonal. Planar trigonal is that may indicate the coordination number will be 3. Similarly, if the value lie between 0.225 to 0.414, the void is tetrahedral and coordination number 4. If the value lie between 0.414 to 0.732, the void is called as octahedral, coordination number 6, formed by 6 pair. And if the radius ratio value is greater than 0.732, the void is cubic, formed by 8 sphere. जैसे कि आप simple cubic को imagine कर सकते हो. And the example for the trigonal void is B2O3. For tetrahedral it is ZnS and silica. For octahedral it is NaCl and MgO. And for cubic it's cesium chloride, CSCl. Clear?